Alright, I'm going to go through now how to solve a system of equations with three variables and three different equations. In order to do that, we're going to warm up with some two-variable two-system equation here, or two-equation system. You see here we have x minus 2y equals 8 and x equals 5 minus y. Now, I could try to use elimination. I could add y to both sides, make that to where it's x plus y equals 5 on the bottom equation. But there's a much simpler and easier way of doing that, and that is to just use substitution. Alright, and so to use substitution here, I just need to substitute what x is equal to, which is 5 minus y, in for that x in the first equation. So 5 minus y minus 2y equals 8. Now I can combine like terms. Negative y minus 2y is negative 3y plus 5 equals 8. And I'm trying to get y by itself, so subtract 5 from both sides. I get negative 3y equals 3. And then I want to get y by itself, so I divide both sides by negative 3. And I get y is negative 1. Now I can take that, I can plug it into either one of my original equations. It does not matter which one. X equals 5 minus negative 1. Well, when I subtract a negative 1, the same as adding a positive 1. Alright, so x equals 5 plus 1 is 6. So my solution set is 6 comma negative 1. And just to prove to you that that is correct, I'll plug that into the other equation. 6 minus 2 times negative 1 equals 8. Negative 2 times negative 1 is positive 2. And 6 plus 2 is 8. And 8 equals 8, so it checks out. So we have a good solution set of 6, negative 1. Alright, the next equation system, we have 3x plus 2y equals 9, 2x plus 6y equals 6. We just need to create an opposite pair. An easy way to create an opposite pair would be to turn the y's on top into a negative 6. So I just multiply that by a negative 3. Alright, and so when I do that, I just move it over. Negative 3 times 3x is negative 9x. Negative 3 times 2y is negative 6y. And 9 times negative 3 is negative 27. Bring this one over. Didn't do anything to it, just moving it over. 2x plus 6y equals 6. So then I add these together. Not negative 9x plus 2x is negative 7x. The y's cancel out. Negative 27 plus 6 is negative 21. Divide both sides by negative 7. And I get that x is 3. And now I can plug that into one of my original equations. So 2 times 3 plus 6y equals 6. So that is 6 plus 6y equals 6. Subtract 6 from both sides. I get 6y equals 0. And then, so therefore y has to be 0. And my solution set then is 3 comma 0. Not solution set, but the solution point. And just to prove to you that that is correct, we'll use the other equation. 3 times 3 plus 2 times 0 equals 9. 3 times 3 is 9. 2 times 0 is 0. So 9 equals 9. And that checks out. Alright. So now we're going to solve a system of equations with three variables and three equations. Alright, so the way we're going to do this is we're going to try to create an opposite pair, and we're going to have to do this a couple of times. We've got to figure out which variable we want to try to create an opposite pair of. And I think the easiest one is going to be the z's, looking at these. So I know that if I take this z here, if you look at the first and second equations only, so equation 1, equation 2, equation 3, if you look only at 1 and 2, I can create an opposite pair of z's by multiplying equation 2 by negative 2. And when I do that, I don't do anything with the first equation, leave that as 6x plus y plus 2 z equals negative 28. Bring this over, multiply that by negative 2, so negative 4 times negative 2 is positive 8x. Negative 2 times 2 is negative 4y. And negative 2 times z is negative 2z. And then 4 times negative 2 is negative 8. So I'm going to add those together, and I get 14x. And I get negative 4 plus 1 is negative 3y. The z's cancel out, and I end up with negative 36. So that's one equation. Now what I'm going to do is I'm going to do the same thing with equation 2 and 3, create opposite pair. This time I'm not going to multiply by negative 2, I'm going to multiply by positive 2. Positive 2, and when I do that, positive 2 times negative 4x is positive, or negative 8x. Positive 2 times 2y is 4y. Positive 2 times z is 2z. Positive 2 times 4 is 8. And then I'm just going to bring down equation 3, x plus 5y minus 2z equals negative 5. Add those together, and that gives me negative 7x, 9y, and that is 3. Those z's cancel out. So now I have two equations with two variables. I have 14x minus 3y equals negative 36, and I have negative 7x plus 9y equals 3. Well, I have two options here of how to create an opposite pair. I can cancel out the y's by multiplying the top by 3, or I could cancel out the x's by multiplying the bottom by 2. Now, obviously, if I multiply the top by 3, that's going to create a big number there, that negative 36 times 3. So let's do the other way. Let's multiply the bottom equation by 2 to cancel out the x's. So the top equation I'm not doing anything to. It's 14x minus 3y equals negative 36. This one I'm going to multiply by 2. I don't know why I wrote a 6 there. 2 times negative 7x is negative 14x. 2 times 9y is 18y. And 3 times 2, oh, that's where I got the 6. I just got ahead of myself. Alright, so the x's cancel out. Left with 15y and negative 36 plus 6 is negative 30. So now I am ready to divide both sides by 15. So my y is negative 2. And looking at my multiple choices answers, I can already tell that there's only one solution set that has a y is negative 2. But let's double check. Let's see if we can go back a step and end up getting an x to be negative 3. So negative 7x plus 9. Instead of y, I'm going to write what y is equal to, which is negative 2, equals 3. So negative 7x minus 18 equals 3. Add 18 to both sides. I get negative 7x equals 21. And then divide both sides by negative 7. And I get x is equal to negative 3. Alright, that's what I was hoping to get. Now I'm going to go back to the very first equations. So negative 3 and for x, negative 2 and for y, so negative 3, let's see, negative 10, negative 3 minus 10 minus 2z equals negative 5. So it's negative 13 minus 2z equals negative 5. So negative 2z, negative 13, so I add 13 to both sides. So negative 2z equals 8. And therefore divide both sides by negative 2. And 8 divided by negative 2 is negative 4. And that is what B tells us our options are. So that is how we get that. All right, so going on to the next one, 4z equals 8. I can get that one down to what z by itself just by dividing both sides by 4. And so z, therefore, has to be 2. So it could be A or E. All right, well, given that information, I can go ahead and eliminate B, C, and D. Now I can take the z as 2 and plug that into either of my other equations. Plugging into the third equation isn't going to help super much, but plugging into that second equation would help quite a bit, because then I could do 3x minus 2 times 2 equals 11. Well, negative 2 times 2 is negative 4. Add 4 to both sides gives me 3x equals 15. Divide both sides by 3, and I get that x is 5. Well, that means that it's got to be A. And just to verify that it is A, I'm going to run those two numbers through that last function. So 5 minus 4, we'll leave it as y, plus 2 equals 11. So 5 negative 4y plus 7 equals 11. So subtract 7 from both sides. 11 minus 7 is 4. Negative 4y equals 4. Divide both sides by negative 4. And y is negative 1, which we have there. So A is our answer. All right. The following 3 by 3 systems of equations. 2m plus 5n plus 2p equals 6, 5m minus 7n equals negative 29, and p equals 1. All right, so we have one thing we know for certain, that p is 1. So that means I can take that information and substitute it in for everywhere else I have a p. So 2m plus 5n plus 2 times 1 equals 6. Well, 2 times 1 is 2. So 2m plus 5n plus 2 equals 6. If I subtract 2 from both sides, 2m plus 5n equals 4. So I have an m and an n here. I also have an m and an n in the other one, that's equation 2. So let's look at this. Let's see if we can create an opposite pair to eliminate. Well, if I multiply the top equation by 7 and the bottom equation by 5, I would create an opposite pair of the n's. And then the same thing, if I multiply the bottom equation by 2 or negative 2, the top equation by negative 5 or 5, I create an opposite pair of m's. Probably going to be easier for me to do the m's. That way I'm not multiplying that negative 29 by 5. I only have to multiply it by 2. So let's multiply the top by negative 5, the bottom equation by 2. Alright, bring those over here. So that becomes negative 10m minus 25n equals negative 20. And then this is positive 10m minus 14n equals negative 58. So add those together. Negative 25 minus 14, that's going to be negative 39n equals negative 78. Divide both sides by negative 39. And I get that n is 2. So I have two variables now. I have p and I have n. So all I need left is m. So easily I can just plug those into, actually, let's just go to the middle equation. 5m minus 7 times 2 equals negative 29. So 5m minus 14 equals negative 29. So if I add 14 to both sides, I get 5m equals negative 15. So therefore m has to be negative 3. So my ordered triple is negative 3, comma 2, comma 1. All right. So on your test, this is going to be a big part of the test, is being able to take a situation and write 3 equations based off the situation. So there's some practice problems on your homework that are like this. Please make sure you take the time to do those. So we'll go walk through this one, and then you'll need to do those practice problems on your homework. All right, in 2016, the museum offered individual, dual, and family memberships. So individual memberships we see here at the bottom are X, then we have Y, then we have Z. So for family, so X, Y, and Z. And we're told that individual memberships are 60, dual memberships are 80, family memberships are 100. Museum sells a total of 81 new memberships a month, and they made $6,420 that month. The number of dual memberships purchased is twice that of individual memberships. So we're going to write and solve a system of equations to determine the number of new individual memberships, dual memberships, and family memberships. Okay? So I know that all together they sold 81 new memberships. So when you add up X plus Y plus Z, it equals 81. I also know that they sold $6,420 worth of memberships. So that means that if I take the price of the individual, 60x, plus the price of the dual, which is 80y, plus the price of the family, which is 100z, that's going to be equal to 6,420. So that leaves me with one more thing I need to determine, and that is the number of dual memberships purchased is twice that of individual memberships. Anytime I see the word is, that's where I'm going to put my equal sign. So the number of dual memberships, which is represented by the letter Y, is, so equals, twice that of the number of individual memberships. So 2 times x. So y equals 2x. Okay, so now we are going to plug in y equals 2x. Well, first of all, got ahead of myself. That is my system of equations. I have 3 equations set up there that I'll be able to use to solve to figure out what it is that each membership costs, or not how much they cost, but how much they sold of each one. Okay, so I have x plus y plus z equals 81. So if I do x plus, instead of y, plug in what y is equal to, which in this case is 2x, plus z equals 81, that gives me 3x plus z equals 81. Now, I can't go any farther than that, so I'm just going to leave it like that. So now I am going to take this next equation, 60x plus 80, and again plug in what x is or what y is equal to, which is 2x plus 100z equals 6420, and 60x plus 160x plus 100z equals 6420. So 60x plus 160x is 220x plus 100z equals 6420. So now I have 2 equations that just have x and z. So I can see if I can create an opposite pair. 3x plus z equals 81. I have 220x plus 100z equals 6420. So if I were to multiply this top equation here by negative 100, I would be able to create an opposite pair. of z's. So negative 300x minus 300z equals negative 8100. Keep wanting to put too many ones there. And then here, we're just rewriting 220x plus, why did I write negative 300? I don't want negative 300, I want negative 100. Sorry about that. So plus 100z equals 6420. So now we're ready to combine these. So that gives me negative 80x equals, let's see, 8100 negative 8100. Get my calculator pulled up here. Negative 8100 plus 6420. And that's negative 1680. Then divide that by negative 80. Gives me 21. So I've gotten x by itself. I got that x is 21. So now I'm going to go back a step. Go back to either one of the equations that had two variables. So 3 times 21 plus z equals 81. So 3 times 21 is 63. Subtract 63 from both sides, and we get that z is 18. Okay, so I've gotten two of the three equations. I also can go back to the beginning, one of the original equations. So I could do 21 plus y plus 18 equals 81. 21 plus 18 gives me 39. So y plus 39 equals 81. Subtract 39 from both sides. And I get 42. So that means that they sold in 1 month 21 individual passes, 42 dual passes memberships, and 18 family memberships for a grand total of 81, and they made a total of $6,420. All right, that's it for this lesson. If you have any questions, please shoot me an email or a Canvas message, and I will get back to you as quickly as I can.